So today I'm going to be talking about view components. In specific, it's about the single file view components that many of you probably have heard of or used to some extent. Can I see a show of hands if you've used the single file view components before? Wow, a lot of you. Great. So a lot of you will have the context of what it is, but for those of you who are not too familiar with it, I'm gonna. Okay. I'm going to be sort of taking a few steps back and try to talk about why did we come up with this idea and how does it relate to the previous versions of the ways that we used to deal with front-end development in the past, and how it sort of relates to how we think about UI development now. And then after that, I'm going to be dig into some of the technical details. If you're not super into JavaScript, it might sound a bit too deep for you, but I think it's still worthwhile. It's interesting to know if you use view components to some extent, those internal technical details will eventually help you sort of demystify this whole thing to some extent. All right, so let's get started and think about way back in the days when we probably when you first started programming with PHP. All we think about is this simple model of sending pages from the server to the client. And that's pretty much it, right? Every time you click on a link, you just go to a new page, and we go back to the server, let the server find something different to render, and then send us back. It was all really simple. But then, these are mostly static pages. Static pages are not that useful when we try to build applications. So then we try to start to add things to these pages. And first, of course, they need to look good. So we apply these global CSS style sheets, which is sort of straightforward. Still static pages. But then we realize we need to add these little pieces of interactivity. Hey, there's JavaScript in the browser, so why don't we just throw in some JavaScript? So we throw in these ad hoc scripts, make this little drop down, or make this little form a little bit interactive with some validations. But still, we are still thinking about mostly in a page-based model, while when we need some interactivity, we just sprinkle things onto it. So this actually works for a lot of cases. If you're building simple apps, this works pretty well. And I wouldn't say this is a bad way of doing things, because eventually it really depends on your use case. But as we know, problems always arise when things scale up, when things get big, when your app gets more complex, when there are more features requested by your manager, and your team grows, more and more developers join your team and try to work together. Eventually, you will need to think about maintainability when the things gets big. And in our the classic separation concerns, we try to think about because we naturally evolved from this model, and we still think in terms of having the HTML as the base structure. We have our styles applied on top of it, and then we have some extra JavaScript trying to manipulate parts of the page. So we think in the classic separation concerns, and we divide things into templates, scripts, and styles. And then we try to, a lot of you probably did this by splitting your bigger templates into smaller ones, splitting your big JavaScript file into smaller ones and concatenate them, splitting your CSS with import statements, or simply concatenating them. But and then some of the companies even hired programmers based on the language they work with. They hire specifically CSS developers, JavaScript developers, and put them in different groups and expect them to work on the same product. Probably a lot of you have learned that this ended up causing a lot of back and forth and collaboration friction when we're trying to deal with the scripts and style parts that intrinsically are dealing with the same piece of functionality in this app. So this creates problems. And the classic separation concerns quickly breaks down when we try to tuck everything into a single page, which is trying to deal with more and more content in a single page. So how do we tame this complexity? So the natural way of going forwards is people start to think, hey, a page is a unit of interactivity, and if we just think of our UI as nested boxes, it's all turtles all the way down, and we can divide a bigger page into smaller pieces and smaller pieces into even smaller pieces. The question is, how do we convert our old way of dealing with code to adapt to this new way of thinking about our pages? And then we realize we can still have our separation of concerns. It's just we have to think about on a finer-grained level, right? We are already splitting our templates, scripts, and styles into smaller files, right? In the past, some of you probably have in our web development source code, we have 3 folders. We have JS, CSS, and HTML. And then we throw files based on the extensions into these folders. Then some of us started to organize things differently. We have this folder called like maybe header, logging form, or footer. Then within each folder, we have its own associated template, script, and CSS file. And the difficulty is how do we put all these things together and eventually assemble them back together? Although separating them into these files made the developers' work easier, when we're at the stage of deployment, there are still a lot of questions. So how do we divide this, right? This seems like a nice way. And if we look at them, when we reach into the 3 folders and find the 3 files that are intrinsically coupled to the same piece of functionality, they are in fact components, right? So your header is a component, your footer is a component, logging form is a component. They can be self-contained, and within each of these boundary of responsibility, they can have their own separation of concerns between our good old separation of concerns between templates, scripts, and styles. So it's just a different way of thinking about problem. And when we go even one step further and put all 3 files into the same file, we arrive at this single file component format that many of you have seen in the Vue ecosystem. So this is sort of the higher level thought process of how we arrived at this. And a revelation after I personally have tried this paradigm, and many other developers who have tried this, realize that this co-location of the things that are closely coupled to a single component in the same file is actually pretty awesome, right? Some of you might disagree, but we've found a lot of people kind of like this co-location because it reduces the cost of this mental context switching. Everything you need for the same component is in the same place. You don't have to jump between different file extensions to deal with them, and distributing this component also becomes more straightforward, as we'll see later in this talk. So enter the Vue components and magic. So it's sort of, I believe single file Vue components today works out of the box if you start with a new Laravel installation. But in the early days, before it sort of had this default setup in a fresh Laravel install, it wasn't really easy to go from ground zero and build your configurations all the way up to get everything working smoothly. So this talk is really going to sort of go deep into the technical details and sort of review a lot of the hard work that Jeffrey Wei has been doing behind the scenes in Laravel Mix and all the related things to simplify all of this for all the Laravel developers. And before we go into the details, I want to acknowledge the inspirations. I did not just invent this out of thin air, right? So there's a lot of prior art and inspirations, and there was this Braid project that when I was at Google, it started this idea about co-location for me. And web components, when they first proposed that things can be just inside the same file, was also a great inspiration. And Reactive is a project by Rich Harris, which also had this format of a component inside a single file idea. But it was an in-browser transform, and the thing that Vue did was to take upon these ideas and take a bit step further with build tools, and it's a compilation process. And why do we choose to do it at compile time, right? Because back in, I think, 2013 or 14, so today's browser technology is evolving, and we know there are new specs that's coming out, like web components. And unfortunately, I think Google just recently dropped the push for the HTML import spec. So this is sort of a reflection of the risk of relying too much on spec that's not formally in place yet. And back then, when a lot of the web components related technology weren't fully supported in browsers, but we wanted all some of the good things about them. So how do we get this benefits of these single file components without having to rely on something that's not even in all the browsers yet? The answer is we do compile time processing so that we can simulate some of the things that we want at the compile time, so that the thing we eventually ship to browsers don't rely on any new features from the browsers. So that's the reason, right? So back then, the first iteration of Vue single file components was actually built with Browserify. So Browserify is a bundler. It originally was invented to convert Node.js NPM modules, which were meant to run on the server side inside Node.js, to convert them into a single file of JavaScript that can run inside the browser. And in the process, people start to realize, because we have this bundling process, it's possible to inject these transforms, or loaders in Webpack term, into this bundling process. So before we put everything, concatenate everything together, we have a chance to transform the source code into something different. For example, you can transform CoffeeScript into JavaScript, which was a very common use case back then. Today, very few people use CoffeeScript anymore. But at that time, I look at the whole thing and realize this is also a perfect infrastructure if you want to have single file components. We just treat the single file components as a source format, and then we provide a transform that can somehow parse, process, compile everything, and then eventually just spit out vanilla JavaScript. That's how it does, right? So I wrote a transform called Vueify for Browserify. All the transforms for Browserify ends with ify, so it's just a convention. And I wrote that, and it worked pretty well. And later on, Webpack became the more dominant bundler, and Webpack also provided a much more powerful way of handling transform individual parts inside a single file component. So I wrote the loader for Vue components for Webpack, which is Vue loader. Okay, so here we're going to talk a bit about what Vue loader actually does. Right. So the first thing we do is we take a single file Vue file. We take a Vue file and then parse it. We'll parse it into, because a Vue file is essentially syntax-wise, it's the same as HTML, right? If you've written a simple Vue like prototype, in fact, I still do, right? I open up a single HTML file, I import Vue, I pull in Vue from a CDN, and I just start writing things with some div elements, with some DOM elements, a script tag, and a style tag. And I can instantly load it in the browser and see what's going on. And a single file component is essentially that, but with some, it's like a single HTML file on steroids, right? So we use the same HTML-based parser to parse it into 3 parts: template, script, and style. And then, thanks to Webpack's very complex internal structure, we can pipe the 3 parts further into other loaders. So we can pipe the template into the Vue template compiler, which is responsible for turning raw Vue template strings into JavaScript, into render functions. And we'll talk about what render functions are later. And then the script part of your single file component gets piped through Babel loader or TS loader, so that we can convert your ES 2015 or ES 2016 syntax into ES5 JavaScript that can run in older browsers. Or if you're into types, you can use TypeScript. And then the style parts, we can pipe them through additional preprocessors, for example, less, Sass, or stylus, whatever you prefer. And then we pipe it through Post CSS, which is a general purpose CSS compilation tool that allows us to add a bunch more custom stuff into the CSS. And eventually, we will either extract these compiled CSS or inject them into our application via JavaScript. So this is the bigger picture. So the template part, we compile our template into render functions. For those of you who've never heard this term, a render function in Vue world is a function that returns virtual DOM. Well, this is, in fact, the same for React. So what is virtual DOM? A virtual DOM is a lightweight JavaScript data structure to represent what the actual DOM should look like at a given point in time. So this might start to sound super abstract, but bear with me. Virtual DOM is essentially, we have the real DOM structure. You can have a div, h1, nested p's, and spans, and think about them as nested JavaScript objects. That's pretty much it. That's what virtual DOM is. And the reason we use a virtual DOM is because it provides the flexibility between templates and raw render functions. So we have templates in Vue.js. They are extremely approachable. They're close to HTML, and they are very easy for designers to work with. At the same time, we know that the render function, or the way virtual DOM works, that's pioneered by React, provides a very powerful paradigm for working with declarative UI. It allows you to leverage the full power of JavaScript when you are dealing with extremely complex UI use cases. So we want to provide this flexibility for both. That's why underneath, Vue uses virtual DOM rendering layer, and on top of it, we provide this template as an entry point. And another benefit of virtual DOM is that it decouples our app's rendering logic from the browser environment, because it's virtual, after all, right? So it no longer relies on the real DOM. It means that Vue can run in other environments. For example, in Node.js, to do server-side rendering, it can run inside a JavaScript engine embedded into a native application so that it can power native UI via projects like Weeks or NativeScript. In fact, in the upcoming version of Vue, we are going to provide a more contained version of the Vue server-side renderer, which is no longer tightly coupled to Node.js, which means it can run inside an embedded VA instance. So theoretically, you can run it in PHP via PHP VA.js, and you can use Vue inside Laravel as a templating engine. So that's something we'd like to see in the future. So with all that in mind, Vue's rendering pipeline essentially first compiles template into a render function, then returns a virtual DOM, and we generate the actual DOM based on virtual DOM. And on subsequent updates, the render function returns a new virtual DOM. And here's where the part that gets interesting. We have two copies of virtual DOM, and we use some algorithms to diff them to apply the minimum changes to the actual DOM. So if you've used React or you've read up on virtual DOM, this might already sound pretty familiar to you. But the idea is all of this happens as pure JavaScript, right? Once we are past the first initial compilation phase, there's no longer the DOM string that's present. So the whole Vue template syntax, the template strings, are really just a source format if you're using single-file Vue components. After this build phase, the code that you ship to the browser no longer contains any trace of a template. They're all turned into vanilla JavaScript. So there's a bit more details in here, right? Obviously, we need a compiler to do all this compilation, and that's provided by Vue as well. This thing actually exists if you're using Vue directly without any build tools. It just runs in the browser, does it on the fly. But if you're using single file components, you can consider it doing this ahead of time. So it's kind of like AOT compilation in compiler jargon. And it goes through the same usual compilation steps, like parsing the template into an AST. So your template, a base template like this, gets turned into a data structure like that. So we even have someone even made an app allow you to explore how Vue templates are turned into the intermediate AST representation. And then the AST is piped into the code gen to generate the actual render functions. So taking the AST above, we turn them into the code, the green part underneath. So this may not, if you've used render functions, I think this more or less makes sense now. But if you haven't used it, just think of it as returning a big tree of JavaScript objects. And this is Vue Template Explorer is an app that allows you to explore how your templates are compiled into render functions under the hood. So that's a very quick high-level overview of how the template part is handled. The big takeaway is that templates in single-file components are just converted into JavaScript. And eventually we hold all we get is just a function, a string that represents a JavaScript function in our compilation phase. So, OK, we're done with templates. Now let's think about styles. Okay, so CSS is traditionally pretty decoupled from our JavaScript things because separation of concerns. But turns out, when we're thinking about components, CSS has its own maintainability problem. The biggest of it is, how do you make sure you don't step on each other's toes? Because CSS has this natural cascading behavior. I mean, it's even in its name, right? Cascading style sheets. And the default scope of cascading is global. Any CSS you write, if you write a very generic selector, it can affect anything on your page, even from HTML that's not written by you, right? If you have this like H1 selector in your code and someone else is writing H1, and it can just unexpectedly affect other people's markup, which is not good. So that's why we came up with all these ways of trying to tame CSS with naming conventions like BEM or OOCSS and all that, just so that we don't accidentally affect other people's markup. But when we think in terms of components, it's just, what if the CSS you write inside component is just naturally scoped to that component? Like, there's no chance of it ever affecting anything else. Then you don't even need to think about naming conventions because it's just out of the equation, right? So this is one big thing when you co-locate your styles with your component in the same file. We get a chance to do some compile time magic to make this seamless and easy for you. Okay. So the first step of transforming the CSS in your Vue component is obviously if you opt to use these preprocessors like letsets and stylus, which is a pretty important use case because I know a lot of designers or developers want to leverage the existing ecosystem of mixins or existing libraries written in these preprocessors to help them to work more efficiently. So this is an optional but non-intrusive step. We simply take whatever preprocessor you want and transform your CSS. And then we pipe it through the CSS loader, which is part of the Webpack ecosystem. The job of CSS loader is really resolving a lot of the URLs in your CSS. For example, if you are linking to a file using a background URL, right? Usually when we deploy CSS, we need to think about where this file is eventually deployed and how it's going to be deployed. Its deployed path is relative to the CSS file and where it's deployed. And usually these relationships are not the same with their relative position on the disk as source files. So that's a lot of headache. But with Webpack taking care of these resolution, it becomes more straightforward. You can just link to another image asset using their relative links, using their relative position on as source files on the disk. And Webpack will rewrite everything to make sure they are eventually in the same, using the correct path after they're deployed. So that's a big bonus. And then there is the step of post-CSS, which is essentially parsing, transforming, and regenerating the CSS, which gives us the opportunity to do the scope simulation I talked just about now. So when you're using single file view components and you add a scoped attribute to your styles, right, we generate. So we do two things. The first thing is we use post-CSS to convert all the selectors and the styles you write to make them more strict. We scope them, right? If you look at the right, the original .ret selector gets converted into a .ret selector with an extra attribute selector. This limits everything inside that rule down to all the elements only the elements that has that attribute. And at the same time, because they are in the same file, right? So we know the same template also needs to be transformed so that every element generated in the same template needs to have that attribute attached to them. So this is pure compile time transform, and when you and it works all the way back in IE9. It doesn't rely on any new browser specs or features, right? But it completes the task of scoping your styles in the component to this component only. And it doesn't even leak down to child components. So you won't run into the case where you import a child component and this child component is accidentally its style is accidentally overwritten by a parent component. Of course, you can still do that intentionally using the deep selector if you really know what you're doing. So this gives us a lot of flexibility, at the same time, ease of mind when you're dealing with CSS. Alternatively, if you're into CSS modules, which is another pretty popular way of dealing with CSS encapsulation, we have first-class support for that too, and this is also done at compile time. We inject the we take the CSS file and convert all the class names into a bunch of hash-based class names so that they're unique and doesn't override each other. And then we inject these class names into your JavaScript so that you can use them directly in your templates. Okay, so after all of that, our CSS eventually gets turned into just processed, plain CSS that just works directly in your browser, all the way back to IE9, yes. And the question comes, how do we eventually distribute this compiled CSS, right? In the past, we just think about, we write CSS file directly, and we concatenate them, and then we push this CSS file up to deployment. But with all your CSS scattered across in your components, how do we deploy them? How are they deployed eventually? So the thing is, it's actually pretty flexible. We can decide at deployment time how to eventually deploy them. So one choice is you can extract them using the extract text webpack plugin. And they'll just extract all the CSS from your components, put them together into a single file, and you get your good old CSS file that you can deploy as usual. It's just a CSS file. And this method is better because your CSS file gets individual caching. So for the long term, it also reduces the size of the JavaScript bundle. So it's a little bit, in most cases, a little bit better for production. But there's another strategy, which is leveraging the runtime behavior. We can we can inline all these processed CSS in your JavaScript bundle as just strings. And then when your JavaScript bundle runs, we dynamically inject these CSS as script tags into the head of your document. The advantage of this is that because they are individual style tags, we can update them dynamically. Unlike a statically linked CSS file, there's no way you can change it at runtime. But with style tags in the browser, we control the style tag, and we can update them dynamically, right? So during development, this is critical if we want to have non-intrusive reloading of the CSS. And this is why using this style injection mechanism, we enable hot reload during development. OK, so we've talked about templates and styles. And finally, script is actually the easy part, because simply we just, if you don't use anything, we can just directly take the script as an ES module, right? Because inside Vue components, we export our component using export default. This is the syntax for ES 2015 modules, right? So your component exports an standard ES 2015 module. And even if you're using Babel or TypeScript, after everything is compiled, it's still a module. And the final step is assembling the three things together. So remember, our template was compiled into JavaScript. They are render functions now. Our CSS, if using the extracted strategy, then there's nothing really to do here. But if you're inlining your CSS to be dynamically injected, then they are just JavaScript strings. And we can then, it's also JavaScript. So both your template and styles are now JavaScript. Together with your main JavaScript chunk as an ES module, we simply attach the render functions and the styles inline CSS to your main module. And then we have finally completed this whole process and got one single ES module out of a single file component. And it's pure JavaScript. Okay? So because it's pure JavaScript, you can think of it as just a JavaScript file when you are using it externally. You can import them using the JavaScript import syntax. You can import foo from foo.vue, and what you get is a JavaScript module. This means everything that's supposed to work with JavaScript would just work with single file Vue components. So you can do code splitting. So this is changing this line to this. This is combining the async component syntax together with the dynamic import in ES syntax plus the Webpack's code splitting feature. So it actually takes like, we need to explain three things to fully explain what's going on here. But the syntax is simple enough that the effort of converting a component that's going to be bundled into your main chunk versus this one, what it does is it'll split out this full component and all its dependencies into a separate JavaScript file. And this JavaScript file will be lazy loaded only when the full component needs to be rendered on the screen. So this is critical to make your initial JavaScript bundle smaller. We are building bigger and bigger applications. So when you have run into situations where you have a JavaScript bundle of 1 megabyte, right? Think about how long it takes to download and parse and evaluate and run all this JavaScript on a phone on a crappy network. Right? It's pretty bad. So the way to deal with it is we want to lazy load part of our applications. And with the way single file components work and everything Webpack and Vue provide you, it's really straightforward to just split out part of the application, the whole component tree, into a separate chunk like this. And because they are just files and dependencies, you can distribute them as dependencies, as packages on package managers. So you can distribute them via NPM. I imagine you could probably do it with Composer as well, but I'm not too familiar with distributing non-PHP files through Composer. But the fact that they are just source files means you can package them up and distribute them, share them, reuse them. So this is a great way to share components across your organization. And just remember that if you want to do this, you need to whitelist the package from your Vue loader configuration so that it actually knows to process this file. Alternatively, you can pre-compile your Vue single file components into plain JavaScript and then just distribute them as normal JavaScript. That'll work too. Okay. So a bonus is talking about hot reload. In fact, this is one of the sometimes considered more fancy features, and I think Jeffrey actually spent quite a bit of effort trying to make it work. And personally, I think it is a pretty important feature because it makes the development flow much smoother when you're iterating over front-end UI. And here I'm just going to try to provide some insight into how it actually works under the hood. The first thing is we obviously have our file system containing our Vue components. And in the background, we start. There is a Webpack dev server. This Webpack dev server watches your files and runs a Webpack, continuously runs a Webpack compiler in the background. And whenever you save a file, it just recompiles the things that have changed. And then this dev server is connected to your browser, to the app that you're running. So inside your app, in addition to your application code, there is this like hidden chunk of code that's responsible for receiving events from the dev server. So whenever something changed in the dev server, it'll send some real-time notifications to this client that's embedded inside your browser. This client obviously only exists during development. They're stripped out for production. And eventually, that's relayed to Vue Hot Reload API. And we actually do this in a very fine-grained way. Remember that because each Vue component splits into so many parts, we actually get different separate notifications for each part. So if you edit the template and save it, we'll receive a notification that the template has changed. If you edit the JavaScript, it will receive a notification that the JavaScript changed. And similarly for styles. So we can adopt different hot reloading strategies depending on the type of notification we get. If we receive a notification saying your template has changed, we can recompile the template because the thing we get is already an updated version of the compiled render functions. So we simply replace the affected component's original render function with the new one and tell it to re-render. And we can simply do this because of Virtual DOM. Because Virtual DOM re-rendering is essentially doesn't care about, it doesn't produce much side effects. When we re-render the Virtual DOM, it knows how to diff the old Virtual DOM with the new one. So we can simply tell it to re-render. This is great. We don't need to tear down our component and then recreate it, which means it preserves the current state of the component. So imagine you have some UI that's nested, like you need 5 steps of interaction to finally reach this component that you're currently working on. When you iterate on this component, every time you save, your whole page reloads and you have to do the 5 clicks again to reach that component. How much time you're wasting for every change you're making, right? But with state-preserving hot reloading, after you save, the whole app preserves the current state. The only thing that's changed is the component you're looking at. So that really helps a lot. However, if you edit the JavaScript, for example, so when you edit the JavaScript, the thing becomes more complicated because potentially you could have edited a lifecycle hook, which has some side effects in it. You could have edited just the whole thing, how the component works. So it's impossible to infer the potential side effects that's going to be caused by this edit. So we're going to do a state resetting reload, which completely tears down the current affected component and then recreate an instance of them in place. The good thing is it doesn't affect its parent component or anything. So it only affects the components that has been edited. And finally, the style pods, they are actually updated completely decoupled from our components because we talked about how they are dynamically injected as style tags. And if their content change, we simply update the content of style tag, and the browser will handle the updates for us, which is pretty neat. So after all of this, we talked a lot about the single file components and its technical details. And many times people have asked me, how are they? Oh, I think I missed a V here. They're native web components. They look a lot like web components, right? They provide a lot of benefits of web components as well. but they are not native. And why don't we use native web components? So there are, in fact, a few good reasons why why I personally would lean towards a compile-based strategy versus native web components today. The important thing is today, right? In the future, if everything works as planned, maybe we'll all be using web components one day. But I believe at this very moment, a compile-based strategy still has some considerable advantages. The first is you can mix preprocessors inside your single file view components, right? You get to use Pug or Jade for your templates. You get to use Sass-less stylus inside your components. You can mix Babel or TypeScript for your scripts. All of these are pretty important dev tools that a lot of us have come to rely on. But if you're using native web components, the workflow for that isn't necessarily the best out there. In fact, many times you must stick to the native features that's currently supporting the browser. And you have to be constantly thinking about what browsers you're targeting and how much features you can use or not use and all that. And hot reload, this is just non-existent for web components as far as I know. You pretty much have to reload your page. Less runtime overhead. A lot of the work, because native web components are essentially purely runtime, most of the work it has to do dynamically as the component is defined, is registered and evaluated and booted up on the page. With compile time optimization, we can do a lot of work. We can try to do more work ahead of time instead of deferring it to the browser. So that's essentially, CPU cycle spent on our dev machines is always good compared to CPU cycle spent on your customers' machines. And no polyfill compatibility concerns, which in my opinion is one of the biggest reasons that I'm still conservative about web components. Performance optimization opportunities, as we talked about. So I didn't talk about some of the compile time optimizations that we perform when compiling views templates into JavaScript. There are some smart things we can do. For example, we in fact detect the static trees inside your template so that they don't need to be unnecessarily diffed and updated again. And these things are kind of transparent. They're invisible to the users, but we can do it under the hood, and we can add more and more of these as time goes if we want to, without affecting the user's experience, the developer's experience. The developer can largely, they can even, they don't even need to know about it, but we can still continuously deliver these invisible performance optimizations over time. We can do server rendering with single file components, cross-platform rendering, and more importantly, we're not strict. Although we try to take the good ideas out of these new specifications, we're not really bound to them. We're not really bound by this really slow process of trying to take everything into consideration and come up with the perfect specification. We get the chance to do faster experimentation. We can try out new ideas. And although stability has become more and more important for Vue.js itself, we still get more wiggle room when we're trying out new ideas compared to the more rigorous specification process. So there are a lot of things to be said here, but nevertheless, I still think native web components are really good at cross-framework or framework-agnostic distribution of reusable functionality. So that's the place where it'll shine. And that's also the place where I think a lot of frameworks will eventually converge at. But when you're building something from the ground up for your own use, I still think the compilation step is really, really important in enabling a lot of real benefits here. So to sum up, the single file view component is a standard source format with extensible compilation pipeline. So that gives us a platform to perform evolution with less churn for the users. And that's it. Thank you.